I'm willing to hang out here for a while, but I don't know what.
Don't they kick us out at some point? Or no?
I don't think so. The cleaning people have been through, so it's usually that seems to be the determining factor. So we're good. I mean, I think we just need to make sure we shut the doors. And
I'll probably head out at least at 10 or something.
yeah, well, you're my ride, so
yeah.
So we'll probably pack it up. We'll pack it up. We can spend another 40 minutes or less. So if you want.
Oh, at 10. I thought you said in 10.
No, at 10.
I was thinking,
it's
we'll
nine.
wrap it
It's
up
nine.
now. All right, well, I'll do
now.
like 15 minutes about equality.
Yeah, obviously, I don't like I said.
I'll do like probably
Yeah.
10 or 15 minutes about
Yeah,
equality.
we can do another
Yeah, that's fine.
10, 20, and then start wrapping up.
All right, so the idea is like we have types which are similar, but not the same thing. Right? I mean, these mean the same thing. Logically, as propositions, they are interprovable, right? You can prove one from the other, and the type-related things, we can construct one from the other, and kind of keep the same structure, right? These are really the same thing to us. And so with search, I mean, really, we need to capture this notion if we want to be able to search for one thing and get results for the other. As an aside, no, search will not, the search that I have will not find one of these if you search for the other. So. Success. So there's this notion of type isomorphism, and so this is actually like in the Idris library, and it says that essentially we just need two functions that convert back and forth, and we just need them to be inverses of each other. So if I do one after the other, I get the same thing, either way I do it. And it's an equivalence relation. And if you don't believe me, you can go to the Idris standard library and find the functions which produce the equivalences, right? That given an isomorphism from A to B, it'll give me from B to A, right? And from A to B and B to C, it can produce one from A to C. So the kind of, one of the weird questions we have to ask here is, what does equality mean? And so we have a type that, right, we have that Idris type of equality, and so that's determined by REFL. And REFL has to, essentially it does type unification on the values. And so it's like, well, when do two things unify together? And that's a really nasty kind of notion. And the best thing to say, right, and we have to be able to compare arbitrary things. It could be functions, it can be anything. Mm-hmm. And to really be able to do things with types, we have to do some sort of comparison for equality. So the way I say it is that it's when they're obviously equal, right? Like these are obviously equal, and anything that is obviously reduces to this is what Idris will find. So when we did the map fusion thing in Idris, there were some things that were obvious, and I could just type REFL, and so that's what it's finding. And so it uses this type here and replace, which is what we saw before. So that's the fundamental thing about equality that we have. So in my search, I do a lot of argument reordering, which is a little worrisome because you ask, if I swap around the arguments and then I swap them around again so that they're back to where they were before, do I have the same function? And that's like not something that's really answered by Idris. It's not really something that's answered by type theory almost, except as far as sometimes we have this function extensionality thing. And that just says that functions are what functions do. That if they result in the same value for all inputs, then they're the same. And I kind of don't like this in a sense. I think this is kind of like, it's too strong. It says that your efficient algorithm is the same thing as your inefficient algorithm, that they are equal in whatever sense that means.
And how do you test
as long
that?
as they... So this is an axiom, right? And it's a weird thing. So if you throw this axiom in, you can't really use it to produce equal things. It's like a constructor almost. And so this is getting beyond interest because I don't know how I'd make a constructor for this because the type's already been defined, the equal type. If the equal weren't already defined, I could have a type that has refl and funnext if I wanted. So I could just use another symbol if I wanted that. But this would come in handy kind of for search, where I do want to mess around with the orders and be a little looser. So here's the thing about type isomorphism. If I have two types, and if I have some type that if I have some type that uses one of those types, I can just replace one for the other, and you'll never know the difference, right? So if A and B are equivalent, then M using A is equivalent to M using B, or I should say isomorphic. And the idea is really, all we ever have to do is sometimes construct the type and sometimes get rid of it. And what we can just do for the other type is we just construct one type and then we move it over with one function. And then going the other way, if we want to destruct it, right, we just use the other function. So we use those pieces of data that we use to construct the isomorphism. We use the F and the G. And so this is something that we should kind of be able to prove if we wanted. Well, here's it says proof, but these are more like very heuristic, horrible arguments. In type isomorphism, it's a lot like set bijection. So particularly in the finite case, if two different types have the same number of elements, so finite, then they're isomorphic. And my proof is really lazy here. I'm saying, well, if you're saying it has a number, then it's isomorphic to fin n, which is just all the numbers from 0 to n minus 1. And so we just use the fact that it's an equivalence relation. And so another thing I thought of is, well, you can have a sort of recursive definition of isomorphism if you wanted. You could say, well, the base types, you'll be isomorphic if they're equal. And then, when you're making your isomorphism, you don't need the elements to actually be equal. You just need them to be isomorphic. So that's a little looser and easier, and I don't know. So isomorphism is not enough. Sometimes I want something that's really more general than what I searched for. But if we go too far, like, I don't know if this is what I was looking for if I searched for this. This is kind of stupid. Yeah. So essentially what I wanted to do is come up with some partial order that defines isomorphism, right? That in the equality case, right, where both are greater than the other, that you'd have isomorphism. And
the relation is cover, or?
I don't know what the name is.
Which one are you talking about, that partial order operator?
Just the symbol
thing?
for, yeah.
I don't know what to call it.
Yeah, well,
I mean, how is it different than strict, or, so like normally that would be in a total, like B is greater than A, and it's the smallest thing that's greater than A, right? Is that what you mean?
Oh, no, I didn't know that. I was just looking
I think you
I was just looking
want,
for a funny then greater.
Okay,
I think
so
you want
it's
it without the
okay.
bar at the bottom. I think you just want the
Okay.
like, because that means, well, I think that still holds, but I think I'm trying to remember, because
Least upper bound or something?
yeah, it's well, I mean, it's like essentially I guess greater than, but it's like that's like greater than equal, but it's like the order theory stuff.
There's no transitive thing. There's nothing between.
This is anti-symmetric. What you're defining here.
Yeah.
the anti-symmetric property in terms of orders.
Yep.
So yeah, but I'm actually not sure that that symbol may or may not be right. I'm not sure. Do you think it's wrong? Or
So how can A
it's the wrong
It's
one, or
not.
be bigger than B and then B
I think it's
bigger
just-
than A?
It's like greater.
I don't
than
know
or
if it's
equal
making
to.
the claim.
That sign's
normally,
just supposed to
I
be
was
like a
associating
greater
with
than or
that, which
equal
is
to,
that,
a funny greater than or equal to
B is
sign.
greater than A. But it's
Okay.
also
So
the
what you're
smallest
saying is if
element that's greater than A.
it's sort of like
It directly
interprovability.
A
If I can prove
directly
this thing from
follows
that
B.
thing,
right, but in a
Okay.
and I
partial
can
order,
prove
it'd be
this one
not.
from that one, if I can do both right
Does
the
it
opposite
necessarily
ways, then
need to
they're like the
directly
same
follow?
thing.
We
They're-
have many chains, right?
Yeah.
But there's still no intermediate element in that chain.
Okay, and so this idea I had was about type containment, and this is a really, and especially since we're going through this, this is not like a rigorous definition at all. But the idea was, well, why don't we think of just similar to these isomorphic mappings between types, but we'll just take a part of one of the types. We don't need to look at the whole thing. And then we can use that to make this relationship, which is something like a partial order. And what I want to know is this, that my partial order will really imply that isomorphism. And so there's something called the Myhill isomorphism theorem. It's from recursion theory, and like it looked kind of like what I wanted, but I don't understand at all. So it might be true if the Myhill isomorphism theory applies, or it might not. I'm not sure. Classically, when you're talking about sets, it is true. And so it's called, I think, the Cantor-Schroeder-Bernstein theorem for sets that says, like, if I can map to a subset, and if I can map to a subset the other way, then they must actually be,
Then the
or maybe
subset. If you can map,
it's something like
it's
that.
not like if you
Map invertibly to a subset. Sorry. So it's like if I can map invertibly to a subset either way, then they are the same size. And so essentially that's what I wanted. And so in my search results, I have something that looks like a partial order, where equal is definitely isomorphic. Greater than means, well, it still might be isomorphic. I'm not sure, but it's definitely implies in one way. And so that's how the equality stuff relates to the search. And I'm pretty much done there. Anyone have any questions
I did want to
about
see
anything?
it, so I guess I'm not sure I fully understand it, but yeah, I need to review some order theory here. So cool. No, it's really cool stuff.
I guess we need to have another talk so you can maybe do this one and then go on with your type stuff again.
Curry Howard,
Yeah.
isomorphism? Yeah, that would be
Yeah,
some,
that'd be awesome.
some good stuff.
Well, actually, I was thinking you could do the first part and then redo the first part and then the second part.
Well, we
But
didn't
we
get a
can do the-
recording of it, so that
Yeah,
is-
we didn't record it. I think it'd be cool to actually record it.
First part was a lot of fun, yeah. It's
Yeah,
kind of
I actually would really like to. I would
you know, like the
regret not
game
recording that.
of is this thing inhabited or not?
Yeah,
Oh yeah.
yeah, I thought that was a really good talk. So that was before I got the idea to start recording them. So
Yeah, cool. I could. Yeah, I'd like to especially do a second part that Idris, where you really get to see the Curry Howard isomorphism.
are you going to put the slides up on the?
Yeah, sure.
Okay, cool.
And I'll put those random text files up too.
Yeah, that would be cool too. So yeah, we can put them up on the GitHub, and then if you want to do something with the videos, we can do that. Or I've actually been thinking about just throwing. I've got a bunch of other Haskell videos. I've been thinking about just throwing up onto YouTube because it seems to be easier.
Yeah.
I'm not sure how to
that'd be
put
good.
it. I'm not sure how to do what you did with GitHub. Like, I have enough
Oh,
trouble
the
just doing the
slides?
basics of GitHub. So,
Oh, with GitHub?
yeah, I was trying to do some stuff with that.
Oh, that's easy.
Is it easy? Okay, maybe you can show me how to do that.
No, it's in Arlington.
You just have to make a repository called like your name.github.io.
Yeah, I was trying to do that for my site, and I was just having issues getting it because I was going to try to put some videos up on it, and then I just gave up, and then I was like, I'll just put them on YouTube. This YouTube was like really easy.
Aren't you a software developer? I mean, you can't figure out the projector.
I looked at the guy who can't load Idris packages.
Oh, ouch.
He started it.
Well, so here's a real general question based on total ignorance. There's a lot of stuff going on in this space. So like Agda, how does Idris relate to Agda?
I consider them extremely similar.
Okay.
One of the big differences is Idris is strict by default. Agda is lazy.
Okay.
Agda is another thing that written in Haskell. Agda is a little older, probably I would think more stable, but a little less devoted to compiling programs.
You wouldn't want to do that.
So you mean in terms of practical usability, there's more of a...
There's less of an emphasis. I haven't really used it enough to like compare.
Seems like
in terms of like actually compiling things.
Don't you need some special math keyboard to do Agda?
Yeah.
Oh, right, that was the
that's
fonts
the reason.
thing.
Honestly, that is the reason why I went to Idris because like I see these tutorials and the standard library has these symbols and I need to type them.
And you're gonna be
but
like
they're not on my
searching
keyboard.
It's like all the Greek symbols and just all the math symbols.
You like need
all the
Emacs
symbols
essentially to do it. Although I figured out like you can use like LaTeX notation, so like
you can. Okay.
backslash for all will make the upside down A
Okay.
to
Yeah.
Agda.
Yeah. There's actually this.
Yeah,
cool
because
little-
that's what you should do.
There's actually there's a site called mathurl.com, and that's actually what I use to do it's like you don't have to do all of LaTeX. You can go there and it has a little like menu and you can select things and then you can Google. And I've actually done I do a blog and when I do some math on it. So for that I've never actually gotten LaTeX to work.
Man, admissions of our tech.
Yeah, well, I'm actually really bad. I'm
with.
actually really bad with. I've just gotten really lazy about trying to get like.
LaTeX
software.
is
Well,
pretty
LaTeX
hard
is a
learning
hard.
curve.
It's a hard thing to get working. Yeah. And I mean, the thing about LaTeX is it's designed for like formatting your thesis.
Excuse
and I
me,
just want to.
it's LaTeX. Just
LaTeX. Oh, I'm sorry. Yeah, well, here I've been mispronouncing it. See, I'm not even saying it right. So. But yeah, it's for doing your. See, you start looking at it. It's like page layout and all this stuff, and I'm like, I just want to do an equation. As I found this math URL site, it's like you can just go in and type it, and and actually start to get a little bit of feel for some of the some of the notation. You can just sort of type them in there, and I've done matrices and stuff like big matrix formulas and stuff.
I've tried to
What do
learn
you
it a
do
couple
like
times.
at your jobs? Like if you have to like make a document, what do you use to
Oh,
write
God.
it? Because
Just Word.
I've used
People always
Word
use
and
Word
it's
and I hate
horrible.
it. Yeah.
But I use LaTeX and it's better, but it's still not what I want.
So we do Wiki, we do Markdown, and we do Word, and like none of them are perfect. So it's pretty awful.
Yeah.
I don't know.
I mean, I've been doing Word for so many years that it's just the easiest.
Like if you want to have figures, I guess Markdown is kind of out of it. Right?
No, you could use images. I mean, it's a pain. And actually, I think some of them support LaTeX. The ASCII doc Markdown. You can have LaTeX native.
I kind of like org mode, Emacs org mode. I don't know. I might just drew the I heard people that say Emacs, but Emacs org mode is kind of like Markdown-like syntax, but you can throw in LaTeX when you want to, and
so
Have
it's
a
like a
figure.
document.
What is it?
formatting
It's
thing?
Emacs what mode?
it's basically like a Markdown alternative that's really based on.
But does it make like a
structuring
document?
and stuff. Yeah, yeah.
Like
So
you
like
print?
you'll render it to like HTML or PDF or something,
Okay.
or just a LaTeX file.
Yeah, I was actually reading one time, a guy was saying that you know, he did like all his word processing in Emacs, and it sounded fairly intriguing. I've actually never really used Emacs, so it's always been like, yeah, I should learn Emacs. You know?
Well, that's a whole
There's just too much stuff to learn. That's the problem.
Yeah.
It's like you got to pick your battles. So it's like I've been trying to learn a lot of math, so it's like, well, I could try to learn math, or I could try to learn how to configure like
Yeah.
different software packages. You know, my brain can only handle so many things.
Yes. I mean, what kind of document would it be? Like a document with inline math or
Some math and some figures.
Okay,
Yeah,
like a paper
come on.
almost. Like
LaTeX. That's,
Yeah, like
Yeah,
I
that's
mean, so
especially if you want
like, there was
math
one
in your
point where we were
figures, you have to do ticks.
doing like reports, and just in Word, like if you have a 50-page report, like with headings and captions, inevitably it just doesn't work.
Yeah, things.
I think,
And LaTeX does, but I like LaTeX, but then I don't.
yeah,
Like the compiler errors.
it's got a hard learning curve.
horrible.
yeah,
Yeah.
Like I'm pretty sure I have like errors in this thing, and I just like hit enter and
Yeah.
pray that.
yeah. Org mode is pretty good. It's particularly good at structure and headings and stuff. You know, if you want to have like a top level heading, then you just do one asterisk space and then the title of your heading, and then everything under that until it reaches another heading is you know, under that heading. Throwing a figure in is pretty easy. Doing inline LaTeX is easy. So I ended up writing like my master's project thingy, and it was really easy to start in org mode. And then once I wanted to do like some stuff in LaTeX, it was a little more painful, but I could kind of get through it. So I ended up using it as a LaTeX substitute. And that's my story with org mode.
I wrote actually a manual in, what's it called, XML?
ML?
Yeah, I think that's the one.
Yeah,
It like has a, you know, you put chapter, like title or whatever, and it's like an XML format.
That sounds painful.
And it was painful.
That sounds
And then configuring it to properly generate, it was like an art to get it to be like the left and right hand pages. And